might do it on the inside of the front cover. I'm just going to tell you, right, I have a little overview here. Review, right, concepts. And so really the best way to review for this unit is just go through your booklet, right? So we started to talk about accuracy. Just front cover, the back of the front cover, right? Accuracy. And for something to be accurate, anybody remember what are the two things that we need for accuracy? You can peek a little bit if you want. On your study sheet, you should have this. You need a standard scale. Sorry, unit. Yikes. I should know my stuff, right? You would hope. Standard unit and an appropriate scale. And so those are the two things you need to look for when you're talking accuracy. What else can affect it? So let's say these two things are happening and it's still, your measurement is still off, right? Can be affected by improper use or faulty device. Okay, those are two things that can affect. So if standard unit is a check and the scale is check and it says, hey, why is the measurement still off? Why are we not where we want to be? Then you have to talk about maybe the person didn't use it properly, and you have to give specific examples. Don't just say didn't use it properly. For example, a measuring cup, right? Was there a did you do water before you did flour, or you should have had probably a different cup for each? Sorry. There you go. So this is just accuracy, and then we talked about precision. Oh, I should say this. Accuracy in a nutshell is how close you are, how close to the target. How close to the target you are. That's what accuracy is. Accuracy tries to get it bang on, right? So that's another thing that you should probably, and I would encourage you to read through it because there's more, but this is just a review, right? Just an overview, I would say. Precision, what is it, right? It's the smallest increment of device, right? That's one way of saying it. It's the limitation. The limitation of device is also correct, right? What's the limitation? There's a limit. It can't go past a certain precision level. It needs to round at a certain time. At a certain point, it just needs to round. Okay. Precision, and you can be given a diagram, a measurement, like actually like 24.329 grams, right? Or you can be given the precision in words, right? Markings of, right? Increments of, sorry, I grew up in South America and they made us do handwriting. So then I moved to Canada, I had to do print, and so now it's all a mix. It's a big mix. So if you see markings of increments of, that is your precision. If it says this cup is measured in quarter cups, then you're like, oh, that's my precision. This thing, if I were to visualize it, it would have quarter cups marked off on the outside of the device. Diagram, I honestly don't know if you want me to have anything there, but maybe let's just do a ruler. Okay, 2, 3, 2. Morning. We're just doing this on the back side of the cover, okay? Just a quick review. Is this hard to see for you guys? You're good? You know that there's lots of room in the front, right? If you want to come to the front. I can always feel lonely. I mean, I have some company here. So thank you. The precision would be what? 0.001. Okay, for this particular, there's a correlation there. We know that that's where the action is happening. Like that's the smallest change that can happen, 0.001 of a gram. What's the precision for this one? From marking to marking, it's 20, right? Oh, I should do centimeters. Let's put centimeters there, sorry. Precision is centimeters because you're going 20, 20. That's the smallest increment at that point. And so I will say this, beaker marked in 125 ml increments. Oh, precision is 125. Thank you very much. That was easy. So there's a definition of it, and then there's a practical application of it. Right? You can actually find out what it is. Should I give the formula? P is high minus low divided by gaps. I don't know. I feel like this might come in handy on at least one question on the test, where you're gonna be like, I don't know, I can't guess. Like it's not a nice round number. I know that. Then use this one, right? High minus low divided by gaps. And I'm gonna do this. And then what was the next thing after precision comes? Uncertainty. Okay, uncertainty is the margin of error, right? And it's the amount a measurement can be off by. Margin of error, amount of a measurement can be off by. And it is always half of precision. Always half of precision, underline that, right? So if P is 20 centimeters, then uncertainty is 20 divided by 2, which is 10 centimeters, plus or minus. If P is 0.001 of a gram, then uncertainty is 0.001 of a gram. I would say just write this down for the future, right? You might not need it for this test because you have a good memory, but down the road you might find this helpful. 1, 2, 3 zeros and a 5, right? So you split that in half, you get that as your uncertainty. I'm basically just See, if your precision is 125 mLs, then your uncertainty would be 125 divided by 2. Half of 120 would be 60. So that'd be 62.5. 62.5. This should also help you to make sure your study sheet is up to date. So I'm going to make a line here like that. And I'm also going to make a line on top of uncertainty, kind of chunking it. Right? You have uncertainty, precision, and next is not tolerance quite yet. You have to be able to state measurement plus or minus its uncertainty. You have to be able to do that. So I'm just going to give you an example with numbers, like a number that you're given. So let's say 24.12 degrees Celsius. Let's say this is the measurement you're given. And you're asked to state it like this. I will box this in. Okay? You're asked to state this measurement plus or minus its uncertainty. You first need to find the precision, then the uncertainty, then you proceed to state it like that. Okay, guys? So what's the precision? Yep, 0.01 degrees Celsius. Uncertainty is half of that. And so let's state it. 24.12 degrees Celsius plus or minus, here it is, that's the uncertainty. Boom. So you have to be able to do that. You have to be able to maybe even look at a beaker, see how full it is, and then just make your reading, like where's it closest to, and then make sure you proceed to find the precision and the uncertainty before you do this. One more thing here next to it, combined uncertainty. Combined uncertainty, what is that? Right? Always add uncertainties. I will give you a page number here for this one because it's not going to fit in here. It's going to be too messy. So let me just quickly point you to the combined uncertainty section. Precision uncertainty. I think it's page 25. Yeah. I will say pages 25 and to 26 are examples I gave you on that. And that would have been, if you were here on Monday, you were supposed to have that filled in, right? So that's where, if you haven't done it, I would strongly suggest you do it, okay? And last but not least, what did we do yesterday? Anybody? Tolerance? Tolerance? Yeah, I know. I feel for you, I do, but I'm trying my best here. And that doesn't mean you don't try your best, right? Like, I'm telling you, this is kind of a dry unit. You still give it your all, right? Trust me, if you go post-secondary, doesn't matter what you take, even if it's the thing you like, you're gonna take courses you don't like. You just have to figure out how to make it through, okay? Like a student came back, graduated last year. I have to take statistics for nursing. I hate it. It's like, I know, but you need to do it, right? Tolerance. Tolerance. I will just make sure I get that right. It is the range of acceptable measurements. I like this one. I'm going to summarize it. Measurement variation. So item can still be used. I will go page 37 in case you need more, right? Measurement variation so that item can still be used or is still acceptable. Did I talk about the temperature in your fridge? What's it? Anybody know what it's supposed to be? Think of just think of your hand, right? Take one off. It's always supposed to be 4 degrees. Like your fridge is supposed to be around 4 degrees. I can guarantee you that it will not always be 4 degrees, because if you're like my kids, they open the fridge and they look at it like, what do I want? It's not a TV, close it, right? And then, but in the meantime, it actually temperature probably went up to like 6, 7, whatever. And then you close it, and the fridge has to work again to bring it down to 4. And then somebody opens it again, goes up, and then goes down. But that's okay. It's made to have some sort of tolerance, right? It can't always be exactly what we're aiming for various reasons, right? So this is what you must have for tolerance. You must have the 4 ways of stating it. I will say this. I'm trying to help you, okay? That's what I'm thinking here. Find the following. FF is following, okay? That's short for following. You want to find the max, the min, the tolerance, and the nominal. Nominal is also known as what you're aiming for or the target. This is step 1. Like I'll actually put a little 1 next to it, and I'm going to zoom into it because some of you are probably squinting, right? I blame it on screens that our vision is going. I have like 4 screens in my vision. I can tell already. It's trying to wear those glasses whenever I can. Okay, so the one I want you to have here is tolerance is max minus min. Remember, it's the range. Range is like the difference between the max and the min, right? And then step 2 is rewrite. So there's the max, min. I may not have them in the exact order as you have, but that's okay. Max plus 0 minus tolerance. Min, think of it, min minus 0 plus tolerance. And then this one, nominal plus or minus half of tolerance. Oops, you can't see that because I'm off the charts here in a bad way. There you go. These are your 4 ways of stating tolerance. Okay, should I box them in maybe so they kind of stick out, right? So I have effectively helped you big time to make your study sheet. That's what I've done here. I'll give you some page numbers if you want, like for each section. And I posted the keys. So for example, this one right here, this section, page 20 to 24, and I posted the key. It's in Google Classroom. I don't know, is it just my vision or it seems blurry to me? Everything is just a blur. Okay. And everything else up there, I'm not going to put page numbers because we did a lot of precision uncertainty. Just flip through the book. That you should be able to figure out. And then there is the difference between, what's the difference between uncertainty and tolerance, Mr. Dirksen? Because I'm not quite sure. Uncertainty is just simply because of the limitation of the device. Tolerance, the industry sets the tolerance, what is allowed, because of all the issues, because of people not using the device properly, because of, equipment malfunction, you name it. Like, because of all those things, tolerance is set by the industry. They say, hey, we will allow some variation. Okay, this is it for my review. Now I'll give you an AC. And then we'll do the mock quiz. This one has a lot of old exam questions in it. So let's see how you do with it. It doesn't have, yeah, it does have one tolerance question. Sure, $5. So get your ECs out. Let's correct it. Ready? Get a marker. Paul continually bends and unbends his flexible plastic ruler. It looks like this. Choose the letter that best completes the statement. The aspect of the measurement that is affected is, it has to be accuracy. Remember, improper or faulty device affects your accuracy. Because the precision and the uncertainty stay the same, because the distance between each one of the marks stays the same, right? So accuracy. Okay. Number 2, rake measure is measuring the volume of the liquid. State the precision of cylinder A, and that is 50 mLs. Like if you think about it, right, it goes up by 50 every time. The precision of the second one is 100. Hopefully you got that right. Justify which cylinder is more precise, and you'd have to say cylinder A because it goes up by a smaller increment. Do not say because the markings are closer together. That is not going to be good enough. You have to refer to the fact that the amount each mark represents is smaller, okay? And then 3, it asks, watch what it says here. It states the uncertainty of the measurement. So if you do precision and uncertainty, just make sure you clearly circle uncertainty, okay? That's what they're asking for, 1 mark. So this page is worth 5 so far, okay? Precision is 2 because it goes up by 2. Uncertainty is 1. Next page. Hopefully you're marking this, right? The precision of this container goes up by 0.2. 0.2. Therefore, the uncertainty is 0.01. Okay? It doesn't ask me to do that, guys. It doesn't ask me. This is not the final answer. Watch what it says. Calculate the total uncertainty of the measurement if Marco uses the container 12 times. Like the total uncertainty is what we want. So basically, you can add 0.1 12 times, or you can just say 12 times 0.1, and you get your answer that way. So you would get 1 mark already if the 0.1 shows up, and then another mark for getting the 1.2. If you made a mistake on your uncertainty, that's a -1. If you go 12 times whatever you got for your uncertainty, you still get 1. Okay, so watch carefully. And then you have this yard fenced in, right? The measurements already have their uncertainty given. See that? So what's the maximum length of fencing required given the measurement and the uncertainties above? So what they were asking for is add the measurements and add the uncertainties, and that would give you 1 mark already. And then from there, the max, the longest would be to add these, to add 111 feet plus 2, which gives you 113 feet. That would be another mark there. And then last but not least, the tolerance of a measurement is 0.07. The nominal value, which is the maximum, is this. So here you have to be careful. This is your max, right? This is the max. And if the tolerance is 0.07, you literally have to subtract the tolerance. This number has to be subtracted from the max to get the min. And so now you have the lower limit and the higher limit. Because if they gave you the min, you would add the tolerance to get to the max. If you have the max, you subtract the tolerance to get to the min. So these are your boundaries here. And so 15.91 is above the max, so that's a no-go. This is 15.078. It's just bigger than this, so you're still in here, somewhere in here. This one is too big. This one is too small. Okay, so the only correct answer there is that. So 4 marks for, wait a minute, hold on. I didn't make that a bonus because I wanted you to know it. So no bonus there. So what are we at? So 1 and 2 is 3, and another 2, that's 5. So the back side is worth 5, and the front is worth 5. So 5 and 5 is 10. Right, so we're just going to keep it at 10 as I had it originally. Right, there you go. And if you can just put a mark on it